Hello and welcome. We are looking today at the work of two famous scientists called Rutherford and Marsden, and they did some work on the structure of the atom around about the early 1900s. Now, at that time, the scientists had an idea of what they thought the atom looked like, and they thought it was a nucleus which had the positive charge on it, and they thought the electrons were actually stuck to that nucleus, and therefore it looked a bit like this, like a ball with these electrons stuck onto it. In actual fact, they said it looked like a bit like a plum pudding, so they called it the plum pudding model, and there's our plum pudding of sorts. Okay, so that's what the theory was up until then. Now, these two scientists decided they would test out this model to see if it was actually correct, and what they did was they worked with radioactivity. They had been working on this idea of nuclear radiation, and they had worked with these things called alpha particles which have a positive charge, and they decided to do an experiment using those alpha particles. So the experiment went a little bit like this. We had a very thin layer of gold foil, so this is the gold foil here, and by very thin we mean it was only a couple of atoms thick, so it's very, very thin indeed. And at that gold foil they fired a stream of what we call alpha particles. So let's have a look at that a little bit more closely. So if I was to magnify that area there to the level or to many thousands of times, we would see that the stream of alpha particles were flowing towards this gold leaf or gold foil. Now if I take one of those out, an alpha particle actually is made of 2 protons and 2 neutrons. So the protons carry a positive charge and the neutrons carry no charge. So overall that has a charge of 2 plus. It has an overall positive charge. So if we fire those alpha particles at the gold foil, what they were expecting at the time was that for the alpha particles to pass straight through, or most of them to pass straight through. If we were to look at a little part of our gold foil, we would see it was like this. Now these aren't actually protons or neutrons, these are actually whole atoms, okay, whereas these are just protons and neutrons, so much tinier. The scales aren't quite right here, but it gives you an idea. Okay, so we're firing these alpha particles with a charge of 2 plus at a very thin layer of gold foil, which is just one or two, well, probably 2 or 3 maybe layers of atoms thick. And this is how they set up the experiment. So it was set up in a vacuum chamber. That meant there was no air in there at all, which was important because the alpha particles would or could bump into the air particles, and then this would actually not give a very good set of results. So the air had to be taken out of there. We have our source of alpha particles, which is in this little container here. This is a beam of alpha particles being fired at the gold foil. Here's our very thin gold foil as we saw in the previous slide, and here we have a detector. And the detector could actually move around, so it could detect what was happening or where the alpha particles were going at different times. So you could actually move that around, or there may have been several detectors, but certainly the detectors were used to see what was going on and where these alpha particles were going after they went through the gold foil. Now what they actually found when they did this experiment was that the alpha particles, rather than going straight through, or more or less most of them going straight through, they found that some of them, in fact most of them did go straight through, so loads and loads of them went straight through. But they also found something that was quite curious, in that some of them were deflected, and they were deflected by varying amounts. They also found that some of them actually came straight back, and that was very curious for them. They were wondering why these alpha particles with their charge of 2 plus would actually come straight back, and a very small proportion of them actually did that. Most of them went straight through, the vast majority of them went straight through, but some of them were deflected, and deflected by varying amounts. And they looked at this data and they did some calculations, and they came to a few different conclusions, and those were as follows. So they found that most alpha particles pass straight through the gold foil, and their conclusion for that was that most of the atom is empty space. That means those 2 plus alpha particles had no deflection, no effect, and they just went straight through. Some of them passed through but were deflected by varying amounts. They concluded that there is a positive center to the atom. So there's a small positive center, and these atoms were being or these alpha particles were being deflected by varying amounts depending on how close they came to the center of the gold atom. So if they came very close, they were deflected by quite a lot. If they were close but not that close, they were deflected by a small amount, and so on. And the last observation they made was some, and a very few of them, came straight back, and I've put a little exclamation mark because that was quite a surprise. But their conclusion for that was that the positive center is very dense. So there's a tiny center of the atom, and it's very dense and a very strong positive charge, and that's why those alpha particles, when they went straight or directly at the nucleus, they literally came straight back because of that strong repulsion force of the positive alpha particle and the positive nucleus. Okay, so this is basically an idea of their experiments and what they did, and what you should really be aware of is the experiment that they did, the conclusions they made, and the fact that new evidence can replace or change a theory, and this often comes about by new discoveries or new technology that comes along that helps you to examine something a bit more carefully. Anyway, so that's an overview of Rutherford and Marsden's work. That's me done for this video. Thanks for watching, and I'll see you again soon.